When seeking a 2-pole 50-amp GFCI breaker for an ITE Type QP panel, a helpful resource is a breaker interchange guide. One such guide, published by Square D, identifies Challenger as a compatible brand for ITE QP panels. This means you can explore Challenger's equivalent breaker options. These breakers can typically be sourced from electrical supply houses. It's also possible to find them at larger retail stores like Home Depot or Lowe's. Remember to always consult the specific interchange guide to confirm compatibility and ensure safe and correct installation. Breaker interchange guides are designed to assist in finding suitable replacements for circuit breakers in electrical panels. These guides typically provide information on which brands and series of breakers are compatible with different types of panels. Understanding breaker compatibility is crucial for maintaining the safety and functionality of electrical systems. Using an incompatible breaker can lead to improper operation, potentially causing overloads, short circuits, or even electrical fires. These guides usually have detailed charts and listings that specify which breakers can be safely interchanged. They consider factors such as voltage ratings, amperage, interrupting capacity, and physical dimensions to ensure a proper fit and electrical connection. Consulting a breaker interchange guide can save time and effort in identifying the correct replacement breaker. Instead of relying on guesswork or trial and error, you can quickly narrow down the options to those that are known to be compatible with panel. This reduces the risk of purchasing the wrong breaker, which can lead to delays and additional costs. It is important to remember that interchange guides are only a reference tool and should not be the sole basis for making breaker replacement decisions. Always verify the breaker's specifications and consult with a qualified electrician to ensure that the chosen replacement is suitable for the specific application. It is also essential to follow all applicable electrical codes and safety regulations when installing or replacing circuit breakers. Breaker compatibility is a critical aspect of electrical safety, and interchange guides can be a valuable resource for ensuring that replacements are made correctly. They provide a systematic approach to identifying suitable breakers, reducing the risk of electrical hazards, and ensuring the proper functioning of electrical systems. The interrupting capacity, often measured in kiloamps or k-amps, is the maximum fault current that a circuit breaker can safely interrupt without failing. It's a crucial parameter to consider when selecting a replacement breaker to ensure it can handle potential short-circuit conditions. Different types of electrical panels may have different busbar configurations, which are the conductive bars inside the panel that distribute electricity to the breakers. The breaker needs to be compatible with the panel's busbar design for a secure and reliable electrical connection. UL listing indicates that a circuit breaker has been tested and certified by Underwriters Laboratories, a nationally recognized testing laboratory. UL-listed breakers meet specific safety standards and performance requirements, providing assurance of their quality and reliability. When replacing a circuit breaker, it is important to match the original breaker's voltage rating to ensure compatibility with the electrical system. Using a breaker with a lower voltage rating than the system voltage can lead to breaker failure and potential hazards. Ensure the replacement breaker has the same number of poles as the original breaker. A single pole breaker controls one circuit, while a double pole breaker controls two circuits simultaneously. Using the wrong number of poles can disrupt the electrical system and create safety risks. The amperage rating of a circuit breaker indicates the maximum current it can carry continuously without tripping. It is crucial to match the amperage rating of the replacement breaker to the circuit's requirements to prevent overloading and potential fires. Electrical codes and standards, such as the National Electrical Code or NEC, provide detailed guidelines for the selection, installation, and maintenance of circuit breakers. Adhering to these codes is essential for ensuring the safety and compliance of electrical installations. A ground fault circuit interrupter or GFCI is a type of circuit breaker that protects against electrical shocks by detecting ground faults. GFCIs are commonly used in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters or RFCIs are designed to protect against electrical fires caused by arcing faults. RFCIs detect abnormal electrical arcs and quickly trip the circuit to prevent fires from starting. Always turn off the power to the circuit before replacing a circuit breaker to avoid electrical shock. Use a voltage tester to verify that the circuit is energized before proceeding with the replacement. Visually inspect the replacement breaker for any signs of damage or defects before installing it. Do not use a breaker that is cracked, broken, or has loose parts. When installing the replacement breaker, make sure it is securely seated in the panel and properly connected to the bus bar. A loose connection can cause overheating and potentially lead to a fire. After installing the replacement breaker, test it to ensure that it is functioning correctly. You can use a circuit tester to verify that the breaker trips when a fault condition is simulated. Keep a record of all circuit breaker replacements, including the date, location, and type of breaker used. This information can be helpful for future maintenance and troubleshooting. If you are not comfortable replacing a circuit breaker yourself, it is best to hire a qualified electrician. Working with electricity can be dangerous, and it is important to have the expertise and experience to do the job safely. Understanding the different types of circuit breakers and their applications can help you make informed decisions about electrical safety in building. There are many types of circuit breakers like standard thermal magnetic breakers, ground fault circuit interrupters or GFCIs, arc fault circuit interrupters or RFCIs, and high interrupting capacity breakers. Standard thermal magnetic breakers are the most common type of circuit breaker, and they are used in a wide range of applications. They protect against overloads and short circuits by using a thermal element that heats up and trips the breaker when the current exceeds its rating. They also use a magnetic element that trips the breaker quickly in response to a short circuit. Ground fault circuit interrupters or GFCIs are designed to protect against electrical shocks by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs quickly trip the circuit when a ground fault is detected, preventing serious injury or death. Arc fault circuit interrupters or RFCIs are designed to protect against electrical fires caused by arcing faults. An arcing fault occurs when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. RFCIs detect the unique characteristics of arcing faults and trip the circuit to prevent fires from starting. High interrupting capacity breakers are designed to handle high fault currents such as those that occur in commercial and industrial settings. They have a higher interrupting capacity rating than standard breakers, which means they can safely interrupt a larger amount of current during a short circuit. Different types of circuit breakers have different tripping characteristics, which determine how quickly they trip in response to an overload or short circuit. Some breakers are designed to trip quickly, while others are designed to trip more slowly. The tripping characteristics of a breaker should be matched to the specific application to ensure proper protection of the electrical system. There are several standards that govern the design, testing, and certification of circuit breakers. These standards help to ensure that breakers are safe and reliable. Some of the most important standards for circuit breakers include UL 489, which is the standard for molded case circuit breakers and circuit breaker enclosures, and IEC 60947-2, which is the standard for low voltage switchgear and control gear. The National Electrical Code or NEC provides detailed requirements for the installation and use of circuit breakers in buildings. The NEC covers topics such as breaker sizing, overcurrent protection, and grounding. Adhering to the NEC is essential for ensuring the safety and compliance of electrical installations. Circuit breakers are designed to be reusable, but they can eventually wear out or become damaged. If a breaker trips frequently or shows signs of damage, it should be replaced. It is also important to periodically test circuit breakers to ensure that they are functioning properly. Circuit breaker testing can be performed by a qualified electrician using specialized equipment. When selecting a circuit breaker, it is important to consider the specific application and the requirements of the electrical system. Factors to consider include the voltage rating, amperage rating, interrupting capacity, and tripping characteristics of the breaker. It is also important to choose a breaker that is compatible with the electrical panel and meets all applicable codes and standards. Circuit breakers are an essential component of electrical safety, and it is important to understand how they work and how to select the right breaker for the job. By following the guidelines and consulting with qualified professionals, you can ensure that electrical systems are properly protected and that electrical hazards are minimized. Before replacing a circuit breaker, you should identify the load on the circuit. This information is important for selecting a replacement breaker with the correct amperage rating. You can identify the load on the circuit by looking at the labels on the appliances and equipment that are connected to the circuit. The labels will typically indicate the voltage, amperage, and wattage of the appliance or equipment. You can also use an ammeter to measure the current flowing through the circuit. If the load in the circuit is too high, it can cause the breaker to trip frequently. In this case, you may need to reduce the load on the circuit or upgrade the breaker to a higher amperage rating. When selecting a replacement breaker, it is important to choose a breaker that is compatible with the electrical panel. The electrical panels are designed to accept specific types of breakers. Using an incompatible breaker can damage the panel or create a safety hazard. You can determine the type of breaker that is compatible with the panel by looking at the panel's labeling. The labeling will typically indicate the type of breaker that is required. You can also consult with a qualified electrician to determine the correct type of breaker for the panel. After installing a replacement breaker, you should test it to ensure that it is functioning properly. There are several ways to test a circuit breaker. One way is to use a circuit tester. A circuit tester is a device that can be used to check for voltage and continuity in a circuit. To test a breaker with a circuit tester, turn off the breaker and then connect the circuit tester to the breaker's terminals. If the circuit tester indicates that there is voltage on the terminals, then the breaker is not functioning properly and needs to be replaced. Another way to test a breaker is to use a multimeter. A multimeter is a device that can be used to measure voltage, current, and resistance in a circuit. To test a breaker with the multimeter, turn off the breaker and then connect the multimeter to the breaker's terminals. Set the multimeter to measure resistance. If the multimeter indicates that there is resistance between the terminals, then the breaker is not functioning properly and needs to be replaced. If you are not comfortable testing a circuit breaker yourself, you should hire a qualified electrician to do it for you. Working with electricity can be dangerous, and it is important to have the expertise and experience to do the job safely. Circuit breakers are an essential component of electrical safety, and it is important to understand how they work and how to select the right breaker for the job. By following the guidelines and consulting with qualified professionals, you can ensure that electrical systems are properly protected and that electrical hazards are minimized. The process of replacing a circuit breaker involves several steps. Firstly, it is important to turn off the power to the circuit at the main electrical panel. This is done by switching off the breaker that controls the circuit you will be working on. Secondly, remove the cover of the electrical panel to access the circuit breakers. Be careful when removing the cover, as there may be exposed wires behind it. Thirdly, identify the circuit breaker that needs to be replaced. It is usually labeled with the circuit it controls, such as lights or outlets. Fourthly, use the circuit tester to verify that the circuit is energized before touching the breaker. This will help prevent electrical shock. Fifthly, carefully remove the old circuit breaker from the panel. This usually involves loosening a screw or clip that holds the breaker in place. Sixthly, install the new circuit breaker in the same location as the old one. Make sure it is securely fastened to the panel. Seventhly, replace the cover of the electrical panel. Make sure it is properly aligned and screwed in place. Finally, turn the power back onto the circuit at the main electrical panel. Test the circuit to make sure the new breaker is working properly. If the circuit does not work, turn the power back off and check the wiring and breaker connections. If you are unsure about any part of the replacement process, consult a qualified electrician for assistance. Electrical work can be dangerous, and it is important to take precautions to avoid injury. Always follow the manufacturer's instructions when installing or replacing circuit breakers. Make sure to use the correct type and size of breaker for the circuit. Using the wrong breaker can damage the electrical system and create a safety hazard. It is also important to keep the electrical panel clean and free of debris. Dust, dirt, and moisture can damage the breakers and other components in the panel. Regularly inspect the electrical panel for any signs of damage or wear. If you notice any problems, have them repaired by a qualified electrician. By following these tips, you can help ensure the safety and reliability of the electrical system. Always prioritize safety when working with electricity. If you are not comfortable performing a task, seek help from a qualified professional. They have the training and experience to handle electrical work safely and effectively. Understanding basic electrical concepts can also help improve overall electrical safety. For example, knowing the difference between volts, amps, and watts can help you choose the right appliances and equipment for electrical system. Volts measure the electrical potential difference, amps measure the current flow, and watts measure the power consumption. Always be aware of the potential hazards associated with electricity. Avoid contact with exposed wires or electrical components. Do not overload circuits or use damaged electrical cords. If you experience an electrical shock, seek medical attention immediately. By taking these precautions and staying informed about electrical safety, you can help protect yourself and others from electrical hazards. It is also important to educate children about electrical safety. Teach them not to play with electrical outlets or cords. Explain the dangers of touching exposed wires or electrical appliances. Supervise children closely when they are around electricity. By teaching children about electrical safety from a young age, they can learn to avoid potential hazards and stay safe. Electrical safety is a shared responsibility. By working together can create a safer environment for all. This includes homeowners, renters, electricians, contractors, and manufacturers. Everyone has a role to play in promoting electrical safety and preventing electrical accidents. Remember that electrical codes and regulations are in place to protect people and property. Adhering to these codes is essential for ensuring electrical safety. If you are unsure about any aspect of electrical safety, consult with a qualified professional. They can provide guidance and advice to help you make informed decisions. By prioritizing electrical safety in all aspects of life, we can reduce the risk of electrical accidents and create a safer world for all.